Hey everyone, welcome back. In this video we're going to continue solving linear equations, and we're going to be looking specifically at how to use the distributive property. First, we're going to start off with area models. So you'll see those square, rectangle stuff at the top. We're going to look at how to deal with those and what it really means. Bear with me, it's not going to make so much sense if you're new to variables right at the beginning, but I'll try to do it a little bit with numbers and you'll kind of see how it plays out. So just looking at the top here, you have A here, B along the top, and C along the top. Remember that variables represent numbers. They mean something. They represent something. So don't worry on the fact that they're just letters now. They mean something. So what we're actually saying with this A, B, C here is we have this A times B plus C. So when you're multiplying two numbers and you're using an area model like this, for example, as a simple case, what we're really doing is we have a length and we have a width, and we're doing 2 times 2. It's the same thing that we're doing here. We're doing A times B plus C. B plus C is just the whole length, but we're breaking it down. Because you'd probably agree with me here that 2 times 2 is going to give me 4, which is also going to be the same as 2 times 1 and 2 times 1, which is just the same thing, just split up, right? 1 plus 1 is 2. So when I do the areas of these two smaller boxes, it's still going to add up to 4. It's the same thing, and that's all I did with the B and the C here. These two things together just make up that total area that we're going to be looking for. Probably still not making sense, but hopefully you understood what I meant by the ABC here. So in finding the area, using an area model, what we're really doing is we're going to be multiplying these two things. We have the A times the B, and A times B is just AB. And then we look at the other box here that we don't have yet, and we have A times C is AC. The distributive property with the area model is just going to allow us to say that the combined areas in these two parts is actually the same as just multiplying the length and the width. So A times B plus C is actually the same as AB plus AC. What that allows us to do later is to break things up, to expand things, and then we can combine using that stuff we learned in the last video, all those like terms, and sometimes things just get a whole lot easier when we do that. Let me try the same thing again, but with numbers. So instead of A, B, and C, just random letters, let's try with numbers and see if it makes sense to you here. Let's try 7 here, and I'm actually going to draw 2, and I got 7 on both sides. Okay, and I have 10. Okay, 7 times 10, you'd agree. When I multiply those things together, I get 70. Not 76. What is that? I get 70. Instead of saying 10, I could also say 5 and 2, right? No, I can't do that. I could say 5 and 5, because 5 and 5 together make up 10. So if I do 7 times 5 and I get 35, I do 7 times 5 and I get 35 again here, then the sum of these two, 35 plus 35, is the same as the 70 here. Okay, hopefully it's starting to get clearer. All right, let's move on with the actual stuff, and it'll come together. So it says show the area of the rectangle as a product and as a sum. So the area of the rectangle as a product is A times B plus C, and it's also as a sum AB plus AC. Okay, let's move forward with examples. Distributive property is a tough thing to understand without looking at examples. It's just one of those things you gotta see a few times and then you'll start to get it. Setting up an area model here. So I have a 7, and then here I have C plus 2. I have C here and a 2 here. So the top right here, this whole top is C and 2, C plus 2. Now to do the area models, I just have to multiply all the individual widths and height, widths and length, or whatever you want to call it, and see what the area is. So 7 times C is 7C. 7 times 2 is 14. So the sum of the two areas is 7 plus 14. That's all there is to it. 7C plus 14 is just a different way of saying 7 times C plus 2. All right, let's set up the same thing here. 3 on that side, and then A plus B. So the interior here, the area, is 3 times A. And for the other one, we have 3 times B. So the sum of these two are just 3A plus 3B. 3A plus 3B is another way of saying 3 times A plus B. Okay. This is show you know, so this is something that you should try first on your own. You should pause the video here, give it a shot, set up the area models yourself. I can help you with that, and then I want you to try actually solving this on your own using the area models and see if you get the same thing that I got on the next slide. One thing I do want to point out, because it's a common error, notice that it says minus 11. So that's actually a negative 11. Okay, so make sure that on the area model you have a negative 11 here. Same thing with this. We have minus 3x, not positive 3x. That does matter. And be very careful with your negatives when you are multiplying these across. All right, pause the video, give that a shot, and then check your answers. Okay, if you are back with me after trying, then you should have gotten this. I'm going to leave it up here. You can just check your answers, and when you're ready, unpause and go forward. Example 2, expand each expression. This is another way of using the distributive property, but it doesn't require you to do the whole drawing with the area models, which is very tedious. It's a good way to understand what's happening, like the area models are good to understand, but really to draw that out every single time, that's kind of a pain in the butt. So there are, fortunately, easier ways to do this. When you are looking at negative 3 times x plus 5, what really happens, if you look back to the area model, is you are actually multiplying this first number, the one in front here, you are multiplying it by each of the individual parts inside. And that's what the distributive property actually does. I minimized it here. All right, so let's give that a shot. What I like to do is I like to do these little lines to let me know that I've actually dealt with that. Right now there's only 2, but in the future, in upper math, you might have things that are like this. Or even more terms. You might have like 10 terms, who knows? And you have to deal with every single one of them. And you want to keep track of what you're doing. So sometimes little notes, little annotations along the way can be helpful. So let me start this. Minus 3 times x is minus 3x. Then I have the next one. Minus 3 times 5 is minus 15. That's it. Expanded. That's all I got to do. There's nothing more. Move on to the next. Minus 4 times minus 5. 2 negatives make a positive, and 4 times 5 would be 20. So that's positive 20. Then I do the next. Minus 4 times a is minus 4a. And remember, it's pretty standard to put your variable in the front, so you should actually represent this afterwards as minus 4a plus 20. And this one's just fine on its own. Okay, now you're on to a show you know. Just do the same thing. Distribute it across. Remember the word distribute, you just distribute this thing to all of the individual parts on the inside. Pause the video, give that a try, and check your answers. Okay, hopefully you did that, and you got these same answers. Minus 6x plus 18, two negatives make a positive. Then you have 5 times 8 is 40, and 5 times negative c is negative 5c. I forgot to do this. Variable in front, so it should actually be like that. That's a 40. Okay, moving forward. This is the last page for this video. Simplify each expression by expanding. That's what we just did. And then combining like terms. That's what we did in a previous video. So when we expand, we're going to have, with all these other extra things on the side, we're going to have extra bits that we will be able to put together and kind of shrink it down to make it look a little nicer. Let's try this one first. 7w, 7 times w is 7w, and then you have 7 times 3 is 21, so that's plus 21, and then I still have a minus 10 left over. I'm looking for like terms. Are there any more w's? No, so that's the only w I have, 7w. But the 21 and minus 10, neither of them have variables, they're just constants, so I can combine those. 21 minus 10 is just 11. So this is the most simplified form of this. They are exactly the same thing, they mean the same thing, there's no difference except in the way that we represent it. I think 7w plus 11 is a lot easier to look at than 7 times w plus 3 minus 10. And you'll kind of see that even more with these next crazy ones. They get easier. This is like the only kind of math that you're actually making it easier in the process of solving it. Okay, so 15. 15, nothing much we can do with that yet until we're ready to combine. And then we have minus 3x minus 2 minus 20. This is going to be trouble for some people. Remember that subtracting by 3 here is the same as adding by negative 3. They mean the same thing. So what I'm actually looking at here is plus, I'm just going to rewrite the whole thing to be a little more clear, plus negative 3 times x minus 2 minus 20. Now when I'm going to distribute that, I'm going to use that negative up. I'm going to run this through, so I have 15 still, and then I have minus 3 times x, so that's minus 3x. Then I have minus 3 times minus 2 is positive 6, two negatives. Then I still have my minus 20. Now I can look at combining all my terms. I have one x term here, so that's just that one alone, minus 3x. Then I have a bunch of constants. 16 plus 5 is 21. 21 minus 20 is just 1. So this is what I end up with. Minus 3x plus 1 looks a lot nicer than what I started with. Okay, one more to try out. If it helps, sometimes you can just kind of like work on expanding these separate and then pull it together. Let's give that a shot. Maybe that'll help some people. So I'm going to just expand these first and just kind of do it in the margins up here. I have 5y, and then I have 5 times negative 1 is just minus 5. So I know that this bit right here is the same as that. That's the expanded form up here. All right, and over here I have minus 2 times minus 10 is positive 20, and then minus 2 times y is minus 2y. Okay, so now when I'm reading through and reorganizing all this, I know that this stuff is right here and this stuff is right here. This isn't the way that I do it, but some people might find it useful to do that. I prefer just doing it a straight line all the way through, but whatever floats your boat. Minus 6. So I have my minus 6, and then I have 5y minus 5 plus 5y minus 5. Here I had plus 20 minus 2y, and I have plus 1 left over. Now I combine like terms. I'm noticing that I have a couple y terms. So I have 5 y's here, and then I have minus 2 y's here. 5 minus 2 is 3y. That's dealt with, and that's dealt with. Now I have constants. Minus 6, minus 5, plus 20, and 1. So minus 6 and minus 5 together are minus 11. I can just add 1 there. That's minus 10. And now I add 20, and that is a positive 10 at the end. Here's my final form. 3y plus 10 is the exact same as this whole mess up here. I've expanded, and then I combined. And now we've reached the end. We can stop.